Hello students, welcome you to this session. In this video, I am going to teach the objective questions from chapter number 7, Applications of Differential Calculus. Question number 1 to 10, I taught in the previous video. Those who have not watched, you can watch that one. So here from question number 11 onwards. Okay, let's move on to question number 11. A function sin raised to 4x plus cos raised to 4x is increasing in the interval. So for increasing, what's the condition? First derivative, f dash x is positive, right? F dash x positive, increasing, negative, it is decreasing. And here you need some trigonometric identities. What is sin 2a? 2 sin a cos a. Cos 2a, there are 4 formula, but the basic one is cos square a minus sin square a. So I'm taking the given function as f of x, sin raised to 4x, plus cos raised to 4x. If we differentiate f dash x, sin raised to 4x, x raised to 4 type, right? Sin raised to 4x derivative, 4 sin cube x into the sin x derivative cos x. Plus cos raised to 4x, again x raised to 4 type. Cos raised to 4x derivative, 4 cos cube x into that cos x derivative minus sin x. That minus I'm writing here, okay? Minus sin x. Now you see what is common here, 4 sin x cos x. If I take 4 sin x cos x outside, you will get sin square x minus cos square x. But cos square x minus sin square x, we have a formula, right? Cos 2a. So what I'm taking a minus sign also outside. Minus is not common, but still I'm taking minus outside. Minus 4 sin x cos x. If you take this, then this minus term, this become plus, right? So you will get, we have taken minus 4 sin x cos x. So what is left out? Cos square x. And the first term become minus. We have taken 4 sin x cos x as sin square x is there. Now listen, the second bracket cos square x minus sin square x, that is cos 2x. And here also we have sin x cos x, right? If we have a 2 sin a cos a sin 2a, so this minus 4 we split. Minus 2 into 2 sin x cos x. Into cos square x minus sin square x is cos 2x. Now here you combine this part, 2 sin x cos x, that is sin 2x, right? So in the next step, minus 2 into 2 sin x cos x is sin 2x into cos 2x. Once again, this is of the type 2 sin a cos a. This is our a now. So your answer is minus 2 sin a cos a sin 2a, sin 2 into 2x. So you are getting minus sin 4x, right? Minus sin 4x. So this is f dash x. Question is increasing, decreasing in the interval. Okay, so in which interval they are? So maximum they given what? 3 pi by 4, pi by 2 is there. Okay, let us see. So for increasing, decreasing, you find the stationary point. First you put f dash x equal to 0. Minus cannot be 0. So sin 4x is 0. This is of the type sin theta 0. Sin theta 0 means theta equal to n pi, right? Trigonometric equation. So which implies 4x is equal to n pi. So x is equal to n pi by 4. So first you put x equal to n equal to 0. When you put n equal to 0, you are getting x equal to 0. When you put n equal to 1, you are getting x equal to pi by 4. When you put n equal to 2, x equal to 2 pi by 4. Cancel pi by 2. Okay, a lot of points you got it. So put all these in a number line. So 0 is there. 0, 45, pi by 4, pi by 2, 90, and so on. Let us see. You take, in this interval, you take any point. Between 0 and 45, you take, suppose you take a point 30. I'm taking a point 30, pi by 6. 30 you substitute in the first derivative. This is f dash x, right? This is f dash x. So if I substitute 30 here, for x I put 30. In f dash x, for x I put 30. 4 into 30, 120. So sin 120. Sine 120, 90 plus 30, right? 120 is in the second quadrant. Sine is positive, but outside we have a minus sign. So plus into minus, totally it is negative, right? So here it is negative, so decreasing. Here it is decreasing, next it will be positive, increasing, then decreasing. So the question is, in which interval the function is increasing? Pi by 4 to pi by 2 it is increasing. Pi by 4 to pi by 2 the function is what? Increasing. Because increasing only they asked. So the correct option is the third one. Now let's move on to question number 12. The number given by Rolle's theorem, that is the C you have to find. For the function, okay. A function interval given is a polynomial function, continuous. For Rolle's theorem, you know there are three conditions, right? Here no, there is no option, does not exist, okay, cannot be verified, they didn't ask, give. So no need to check the conditions and all, any of you will get the value. What is the condition? F dash C equals 0, right? Actually there are three conditions. F of x is continuous in the closed interval 0, 3. Differentiable in the open interval 0, 3. Then f of 0 equal to f of 3, right? F of a equal to f of b. Then there exists at least one c belong to the open interval 0, 3 such that f dash c is 0. Okay, since it's an objective question, straight away I am writing the condition f dash c equal to 0. F dash c, you differentiate one time and replace x by c. X cube derivative 3x square. 3x square. Here instead of x you write c. Minus 3x square derivative 6x, you write 6c equal to 0. Okay, this is a condition. So take 3c common, you are getting c minus 2 equal to 0. So c equal to 0, that you cannot take because c must lie in the open interval 0, 3. Okay, so open interval means the end point is not included. Another value c equal to 2, that 2 belongs to the open interval 0, 3. So the correct option is the fourth one. Now listen the 13th question. The number given by the mean value theorem for the function 1 by x, x belongs to 1, 3. The number given by, again you find c value. For here f of x is 1 by x. So a value 1 and b value 9. Then Rolle's theorem f dash c is 0, right? But here f dash c is equal to f of b minus f of a by b minus a. Substitute f dash c. What is f dash x? 1 by x derivative minus 1 by x square. So here minus 1 by c square. F of b means f of 9, 1 by 9. Minus f of a, 1 by 1. By b minus a, 9 minus 1. So you simplify this. Minus 1 by c, c square, right? Minus 1 by c square is equal to, numerator you take LCM, 9 LCM. So 1 minus 9, right? It is minus 8. Whole divided by 9 minus 1 is what? 8. That 8 will be in the denominator. 8 and 8 you cancel. Minus and minus you cancel. Cross multiply, c square is equal to 9. So c equal to plus or minus 3, right? So the correct answer is minus 3 you cannot take, that is not in the interval, right? So here c equal to 3, that belongs to the open interval 1, 9. Okay, the value which lies in that interval, that alone you should take. Okay, there is a similar question in our exercise. So to prove that question, it is exercise in 3.5, fifth question, the first part. Show that the value in the conclusion of the mean value theorem for the function fx equal to 1 by x. Here also we got the same function, right? The interval root ab is root ab, the function 1 by x. Then the value in mean value theorem, the interval ab is root ab. If you are remembering this, straight away you can do that, right? Because here the function is what? 1 by x only. The function is 1 by x. ab, it is 1, 9. So the answer is root of AB. Root of AB means root of 1 into 9. So root 9, it is plus or minus 3. Straight away you are getting the answer. Okay. So the theory questions, wherever possible, you try to remember the answer with the question, so that sometimes some objective questions will be easy for you if you apply the question directly. Okay. Now let's move on to question number 14. The minimum value of the function modulus 3 minus x plus 9. So for this you no need to break your head. Okay, it's a very simple thing. Just some general knowledge, if you know, you can do that. Please listen. The minimum value of 9 is 9 only, is a fixed one. Minimum value of the absolute number, modulus value cannot be negative, right? It will be positive. It can be 0. So minimum value of the modulus value is what? 0 only. So your answer is 0 plus 9. It is 9, right? The minimum value. See the 15th question. The maximum slope. Slope you have to maximize. For maxima minima, so local maxima, local minima would have studied. You have to differentiate 2 times. But in this question, not maximizing the given function, so maximize the slope. So first you find slope. Slope itself dy by dx, okay? So differentiate 1 time, take that as slope, then that slope you differentiate 2 times. Okay, so please listen carefully. So y equal to e raised to x into sin x. Interval 0 to 2 pi. So first I'm finding slope. Slope means dy by dx, right? Slope is equal to dy by dx. So m equal to differentiate, apply product rule. First into e raised to x into first into derivative second sin x derivative cos x plus second into sin x into e raised to x derivative e raised to x itself. So m equal to, take e raised to x outside, you are getting sin x plus cos x. So this is slope. Slope we have to maximize, right? Maximum slope. At which point? So that is x value, that alone enough, right? The critical number, the critical point is enough. So differentiate 2 times. So first you find dm by dx or m dash x. Apply product rule first, second. So first into second derivative, sin x derivative cos x derivative minus sin x, plus second into, that is sin x plus cos x into e raised to x derivative e raised to x itself. So take e raised to x common, cos x minus sin x plus sin x plus cos x. So you can cancel plus sin x minus sin x. Cos x plus cos x is what? 2 cos x, right? So you are getting e raised to x into 2 cos x. This is the first derivative. You differentiate again. D square m by dx square. 2 e raised to x. First function, second function. First into cos x derivative minus sin x. Plus second into, that is cos x into derivative of first 2 e raised to x derivative 2 e raised to x itself. Now you can take 2 e raised to x outside, right? So 2 e raised to x, if you take outside, you are getting cos x minus sin x. You are getting cos x minus sin x. Okay, now please listen. The first derivative 0, dm by dx equal to 0. First derivative 0 means 2 e raised to x into cos x equal to 0. E raised to x 0 means it is 0. That is one end point. Then cos x 0. Cos x 0 means cos x equal to 0. That is x equal to pi by 2, right? X equal to pi by 2. Substitute in the second derivative when x equal to pi by 2. So option pi by 2 is there. But only thing you have to check whether it is what? Maximum. Maximum means second derivative must be negative, right? So when x equal to pi by 2, d square m by dx square is, listen, d square m by dx square is 2 e raised to x. 2 e raised to x. You are giving pi by 2, right? Cos pi by 2 0 minus sin pi by 2 is 1. So you are getting minus 2 e raised to x negative. So therefore slope m is maximum at x equal to pi by 2. If you want what is the maximum slope, that pi by 2 you substitute in this one, right? It's an objective question, but hope you understood everything. Okay. So the correct answer is the second option. Now let's move on to question number 16. The maximum value, the previous one, maximum value occur at which point? That is only the x value. But here the maximum value they asked, after finding x value, you have to substitute in the given function. Okay. So x square e raised to minus 2x and x is greater than 0. All these are hints. X is greater. Suppose when you find x, you get 2, 3 values. Here x is greater than 0. So don't look at the other values and all. Only positive value you take and substitute. Okay. We take the function as f of x, or you take it as y. Y is a function of x. So find y dash, apply product rule, first, second, first into derivative second, e raised to minus 2x derivative e raised to minus 2x into minus 2, plus second into e raised to minus 2x into x square derivative 2x. What is common in both? 2x e raised to minus 2x is common, right? So I'm taking the second term first, it is positive 1, right? Everything you taken out, so nothing left out, 1. Now the first term, the sign is minus, already taken out 2, 1x e raised to minus 2, so only one more x is left out, right? So this is y dash. Now we differentiate the second time. When you find second derivative, here you can see 3 functions, right? To avoid that, what you can do, this 2x you multiply. So what you are getting now, e raised to minus 2x into, by that 2x you multiply, 2x into 1 it is 2x, minus 2x into x is 2x square, right? Now the calculation will be easy, uv. So y double dash is equal to, first into e raised to minus 2x into, derivative of the second one, 2x derivative 2, minus 2x square derivative 4x. Plus second into, that is 2x minus 2x square into derivative first e raised to minus 2x derivative e raised to minus 2x into minus 2. Now you can take e raised to minus 2x outside. The first, what is left out? 2 minus 4x. The second one, please listen, this one you have to multiply by this minus 2. So minus 2 into 2x, it is minus 4x. Minus into minus is plus, 2 2s are 4x square. Now group the like terms. E raised to minus 2x into 2 minus 8x plus 4x square. So this is y double dash. Now equate the first derivative 0. First derivative, yes, this is first derivative. So here either x is 0, but here they said x is greater than 0, so don't take that. Then e raised to minus 2x, it cannot be 0, only when x is infinity, and this part is 0. 1 minus x 0, 1 minus x 0, that means x is equal to 1. So it is a positive value, right? So when x equal to 1, substitute in the second derivative. This is y double dash, right? For x you put 1, so you are getting e raised to minus 2. E raised to minus 2 into, you are giving 1, 2 minus 8 plus 4. So e raised to minus 2 into 4 plus 2, 6, 6 minus 8, 8 is minus 2. You are getting minus 2 e raised to minus 2 negative. So second derivative negative, so you can say there is a maximum. Therefore, y is maximum at x equal to 1, and the maximum value is, for x you put 1 in the given function. The given function x you put 1. So x square, that is 1 square, 1 into e raised to minus 2. 1 into e raised to minus 2, that is e raised to minus 2, or you can write 1 by e square. Okay, so that is the correct answer. So the answer is 1 by e square, that is the third option. Now let's move on to the next question. One of the closest point, that is the nearest one, that the minimum distance is minimum, right? One of the closest point on the curve, on this curve. So after finding one value, you substitute here to find the other one. To the point, okay, now please listen. One point is given, fixed point 6, 0. Another point they given, this is the point we had to find. You take the point as xy. One of the close, so that the distance is minimum. The distance is minimum. I am taking the distance as s. So we have to minimize s. So distance formula, you know, s equal to root of x1 minus x2 the whole square plus y1 minus y2 the whole square. It is 0. So to avoid the root, I am squaring. So when you square, you are getting s square, and that s square I am taking it as a capital S. It's a function, right? So x minus 6 the whole square plus y square. Y square you can find from here. We have x square minus y square is 4. X square minus y square is 4. So y square is equal to x square minus 4. Substitute here. So s equal to, expand this x minus 6 the whole square, a square minus 2ab plus b square Plus for this y square, you write x square minus 4. Y square is x square minus 4. You are getting an equation in x alone, right? 2x square minus 12x plus 32 you will get, right? 32 minus 4, 32. So that this distance must be minimum, right? S square is minimum, means S also minimum only, right? Okay, now listen. Differentiate with respect to x. 2x square derivative 4x minus 12x derivative 12. S double dash is 4. It is positive, so definitely it is minimum only, right? Now first derivative 0, you give 4x minus 12 equal to 0. So 4x is 12, x is 12 by 4, it is 3. When x equal to 3, S double dash is positive. So no need to substitute, already it is independent of x, right? 4. Therefore, S is minimum when x equal to 3. We want to find the point, right? So you substitute in the first equation, you are getting y square is equal to x square minus 4, right? Y square equal to x square minus 4. So x square, 3 square, 9 minus 4, it is 5. This is y square value. So y equal to root 5. So you say plus or minus root 5. So x value 3, y is either root 5 or minus root 5. So the points are 3 root 5, 3 minus root 5. 3 root 5, 3 minus root 5. 2 points. So it's objective question. The given options, take the best one. Okay. If it is a 2 mark or 3 mark, you write all the steps. Now let's move on to question number 18. The maximum product of two positive numbers. I am taking the positive numbers as x and y. Both are positive. Maximum product is x into y. We have to maximize this product. But p is a function of two variables here, x and y, converted to a single variable. When they are sum of the squares, not the sum of the squares. First you square it. Sum of the squares is 200. So what is y square? 200 minus x square. Y equal to root of 200 minus x square. Now this value is substitute here. So p equal to x into, instead of y, root of 200 minus x square. Now p is a function of x alone. So differentiate 2 times p dash. Apply product rule. So first into derivative second, root x derivative 1 by 2 root 200 minus x square into the inner part derivative 200 derivative 0 minus x square derivative minus 2x. First into derivative second plus second into root of 200 minus x square into x derivative 1. Cancel 1 2 here. You are getting minus x square by root of 200 minus x square, right? Plus root of 200 minus x square. So this is p dash value, right? So I'm not finding p double dash now, it's very lengthy one. So I'm finding p first derivative equal to 0. P dash is equal to 0, which implies, so this is equal to 0. Take the negative term to the right side. So root of 200 minus x square is equal to x square by root of 200 minus x square. Cross multiply root of 200 minus x square into root of 200 minus x square is 200 minus x square equal to x square. Take minus x square to the right side, x square plus x square. 2x square is 200, x square is 100, x is root 100, so plus or minus 10. But they said it is positive number, so you take x is equal to 10. Substitute the first equation, because here only one answer you are getting, no? So definitely it should be maximum only. When you get more than 1 point, 1 point maximum, 1 give minimum, right? You have to put in the second derivative, but here no need to waste time. Positive numbers. So we are taking 2 numbers you are getting, but one is negative, so you can leave that one. So substitute the first equation, y equal to root of 200 minus x square. Root of y equal to root of 200 minus x square. X is 10, 10 square 100. So that is root of 100, that is also 10. Don't take plus or minus, 2 positive numbers. So x value 10, y value also 10. The correct option is, so these are the 2 numbers, the maximum product they asked. Okay, so they asked to find the product. So after finding x and y, therefore product is equal to x into y, right? So 10 into 10, so the answer is 100. If they ask the point, it is 10 comma 10. Here the product they ask. So read the question very carefully. Now let's move on to question number 19. The curve y equal to ax raised to 4 plus bx raised to bx square. A into b greater than 0. Normally they say a greater than 0, b greater than 0. But here a into b greater than 0. Something should be there, right? Product of two numbers is positive. When can you say the product of two numbers is positive? What can you say about the sign of a and b? Both may be positive, right? A positive number into a positive number, it is positive. Or a negative number into negative number, it is what? Positive. So a into b greater than 0 means from that what you have to understand? Both are of the same sign. Either both a and b are positive or both a and b are what? Negative. So listen, then what can you say about a plus b? Can you make it 0? Because a is positive, b is positive. Two positive numbers you add, you won't get negative. Sorry, you won't get 0. Suppose a is negative, b also negative. Two negative numbers you add, you won't get 0, right? Anyhow, we'll see. Something should be there. And here some options has no horizontal tangent. Horizontal tangent, okay? And concave upward, concave downward, has no point of inflection. So concavity, point of inflection, you have to differentiate 2 times. And you put second derivative positive, concave upward, second derivative negative, concave downward. Second derivative 0, that is one of the condition for point of inflection. It is the point at which the curve changes from concave upward to concave downward or concave downward to concave upward, okay? So second derivative 0 and third derivative not equal to 0. That is another condition for point of inflection. Using concavity, you can say directly if a function is given to find concavity or to find point of inflection, you differentiate 3 times. You put second derivative 0. At that point, the third derivative not equal to 0 you have to get. Then you say there is a point of inflection. Okay, so these are some information. So let us differentiate 2 times. Y equal to ax raised to 4 plus bx square. What is y dash? A into x raised to 4 derivative 4x cube, right? Plus b into x square derivative 2x. Second derivative x cube derivative 3x square. So 3 4s are 12. 12ax square. 2b into x derivative 1, right? This is the second derivative. So if you put second derivative 0, second derivative 0, so what will you get? Listen, 12 is positive, 12 is positive, x square is positive. So 2 positive numbers into a. So what is the sign of this? This is the sign of a. Because 12 is positive, x square is positive. If a is positive, totally it is positive. If a is negative, totally it is negative. So it is the sign of a, right? Then 2 is positive, 2b, 2 into b, it is the sign of b. So when you add, both are of the same sign, right? Both are of the same sign. When you add, it never becomes 0, right? A and b are of the same sign. Because they said AB is greater than 0. So 2 terms we have, while adding, there is no chance of getting 0 here because both are of the same sign. Both are plus or both are minus. So you won't get 0. So here, y double dash never becomes 0. So there is no point of inflection. Okay, so no need to look into other areas and all. Okay, y double dash x, because there is an option has no point of inflection. For point of inflection, second derivative must be 0. Then in the left side, positive means right side negative, like that. Okay. Now let's move on to the last question, question number 20. The point of inflection of the curve. So directly the method what I said. Here they didn't ask any concavity, convexity and all, right? Point of inflection, differentiate 3 times. Second derivative 0, third derivative not equal to 0, right? So y equal to x minus 1 the whole cube. So y dash, this is of the type x cube derivative 3x square into the inner part derivative 1 only, right? X derivative 1, so no need to write anything. Now y double dash, 3x square type, so 6x, 6 into x minus 1 into 1 only, leave it. Y triple dash is 6 into x derivative 1, so it is 6 which is not equal to 0, right? So now second derivative equal to 0 you give. When you put second derivative 0, 6 into x minus 1 0, 6 cannot be 0, x minus 1 0, you are getting x is equal to 1. Okay, second derivative 0 and third derivative not equal to 0, you say therefore there is a point of inflection. So without concavity, convexity, if you want to find point of inflection, you use this method, okay? So there is a point of inflection at x equal to 1. So here they asked to find the point, right? Yes, so y value substitute y equal to x minus 1 cube, y equal to x minus 1 the whole cube. X value 1 now, so 1 minus 1 0, 0 cube is 0. Therefore the point of inflection is x comma y. So it is 1 comma 0 and that is option number 3. Hope you understood all these things. Meet you in the next video.